All right. Thank you very much, Dave. I appreciate that. So welcome to our latest Workflow 4.0 webinar. Here's a quick agenda for our session today. I'm going to briefly introduce our presenters and then set the stage for their talks. And first up, we've got Kris Nixon with Meridian 3D. He's going to be talking about a tenant-occupied case study right here in my backyard in Washington, D.C. Next up is going to be Greg Hale with Hale Tip, and he's going to be talking about an arena case study, really cool architecture up in Rochester, New York. And then at the end of both of those presentations, we're going to have an Ask the Experts session where we're going to take some questions from the audience and ask these guys about how they perform their project. So just a few rules of engagement here. Everyone's going to be muted during the session except for the presenters. Now, that said, please feel free to ask questions via the chat window during the session. So if you haven't used GoToWebinar before, there's a little chat window over to the right-hand side that you can type your questions in, and please do so throughout the event. Anything that comes to mind, just go ahead and type in a question. We'll get to that at the end of the two presentations. This webinar is being recorded, so we will send out a link to everyone afterwards so that you're able to see this session afterwards. And then just a reminder, please subscribe to Workflow 4.0. That's our e-newsletter for learning as well as sharing experiences, opinions, and best practices. So with that, let me introduce our presenters today. First off, Greg Hale. He's the CTO and co-founder of Hale Tip. Greg, can you just take a minute and introduce yourself, please?
Hi, thanks, Kevin. So I run a company called Hale Technology and Practice. I founded the company a couple of years ago in 2014. It's been running hard ever since. We're a company that specializes in Revit, AutoCAD, and Navisworks, so all of the Autodesk name brands, and then branch out into 3D scanning and mobile technology as a core focus. We are located in Western New York, but practice all throughout the nation. And also on the side, teach classes at Rochester Institute of Technology in Rochester, New York.
All right, thank you, Greg. Next is Kris Nixon. He's the owner and principal at Meridian 3D. Kris, can you take a minute and just introduce yourself and Meridian 3D?
Sure, thank you, Kevin. As Kevin said, my name is Kris Nixon. I'm the PLS and owner of Meridian 3D Incorporated. We were formerly the standalone division of Meridian Associates Incorporated, and Meridian is still up in the Northeast doing their thing, and we work together all the time. But now we are a standalone company focused solely on the laser scanning and CAD modeling side of things. We are in sort of all sorts of sectors, industrial, commercial, building, and we've recently purchased the Hexagon metrology arm, and we are doing work in 3D additive manufacturing now. So as for myself, I've been around laser scanning since day one. Don't know how it happened, but it seems like I've been in this industry a long time now and seen a lot of great changes. And so we're always very happy to speak about ClearEdge, which we think is a very positive development. I look forward to getting to that further, and thank you for having me today.
All right, thank you, Kris. And lastly, myself, Kevin Williams. I'm the Chief Scientist at ClearEdge 3D. And I've been working with laser scan data since the turn of the millennium, is the phrase I like to use. It makes me feel a little older and wiser, but I've been working with it since about 2000. And it's a very cool, exciting field to be in. Lots of new changes, something new happening almost every day. It's an exciting place to work. So with that, let's get started. And up first, we've got Kris Nixon talking about his project here in Washington, D.C. area. Kris Nixon, take it away.
Okay, thank you, Kevin. Yeah, this, at first blush, this was not, it seems like your typical commercial building. But when we really start to get into some of the finer points here, I think you'll see, some of the unique challenges of doing these projects in the lot space. So this was right downtown D.C. I don't know if you're familiar with the D.C. area. The 19th Street is kind of a key shopping area, if you will, and kind of right in the hustle of downtown D.C. So besides the logistical issues of just operating in D.C. and around D.C., this is kind of the area that we're going to find ourselves. All right. See if we can get some click-through here. There we go. Okay. So let me jump back for a moment, a little bit about the company itself. As I said, we were the former standalone division of Meridian. Last year in 2014, right at the end, we split away. And so we finished our first full year of trading and had a very good, successful year. Like Kevin, I saw my first scanner at a surveying convention in, I think, 1998 at a national convention. I was the only person in there talking to them at the time. And I'd like to say I just started right then. Wasn't for a few years later until I actually got to use one. But for years I traveled around the world back in the early SIRA days. Have done oil and gas plants, have done Asia, north of the Arctic. I've done South America. I've done all over the place scanning, and I've really seen it develop from its early days of promise to what it's become today. So with that foundation and with where we develop from, we tend to work in the engineering realm of things. We tend to be doing work that has a precision or critical component to it. I'm going to touch on that a little bit more today. And every industry, every size. Every time I think we've scanned it all, we get something else new that we haven't quite scanned yet. So there certainly is a new challenge every day in this world, as we all know. Okay. So the hard-learned approaches, haven't been in anything this long. You really learn some of the knocks on what works, what doesn't, but how to make that work from schedule and cost standpoint is very important. And I want to touch on that a little bit later in this presentation, but we always try to be very fit for purpose with what we do. There's no point of coming up with something that's going to be an amazing technological achievement if it's not practical for what they're trying to achieve. And we want data access for all, which is one of our core fundamental issues. And I just want to take a second to mention that. The more folks, and we're seeing this in the industry all the time, the more folks get the data, have easy access to the data, can use it through the free viewers, the more they want to use the data, the more it becomes part of the normal process. And we're finding real success in that. Okay, so this project was about 133 square foot medical office building. So it's a very high-end suite with setup right there in DC with secured access right in the middle of DC, very high profile. So it's home to a lot of high-end medical providers right there in the DC area. You kind of go in there and you see it's a little bit of an older building, but it's internally finished to a very high standard. So, and you can see in the image here, I mean, some of it looks like the Starship Enterprise surgical suites here. So the tenants are really, you really have to ensure that we're not going to have any disruption as we got into it. So there's a very critical component for this process. Not only from just the survey side, but in the critical fit-up stage when they actually come in to fit the work, everything needs to be pre-planned so that the absolute disruption to the changeout or to the improvements to the HVAC or MEP system is going to be all planned out, very smooth, go in, work the first time. You don't want a lot of surprises as they're getting into this work. And then because the building has been upfit so many times, there's been a host of changes over the years. So the entire building needs to be analyzed. So we've kind of got not only an individual suite issue, but we've also got a whole building issue. So all of that kind of led us to some unique challenges in this. So there's the usual challenge, which is, has been a key driver for years. You don't have the existing condition drawings where things have changed since it was built in 1955. So there's the obvious usual need to get a rivet model done or to get an existing model done. But another challenge we ran into is that the client came to us, look, we've tried this in the past. So there was a bit of hesitation as well. How are you going to make this work? We've tried it. We know it should work, but good on them for coming back and believing that it could be done successfully. And their critical requirements for first-time fit. So their risk is they're going to run over, tenants are going to get upset, the building owners are not going to be happy with them to the level that it's written into the contract. Then the interstitial space, so what's above the ceilings, all of the ceilings in the suites being different because they've all been refit at different times, but on top of that, there's not much room up there. So you've got small interstitial clearance, so they don't have much room to work with when they do get up there. They won't be able to just do this on the fly to make it work. All right, so what did we do? We had to go in and coordinate each site with the management people. So we go in after hours, and we have to be able to leave no trace. So we go in, many times, most of the floors and most of the suites, they actually didn't know we had been in there. They would be notified, and the tenant was telling us, oh, did you guys actually come last night? So you need to be cognizant of that with our pre-planning. We were able to work through the system with minimal disruption. Again, critical to this was a critical fit requirement, so we went the route of a full measure building survey, which basically means we first created a survey of the building interior of up the stairwells on each level, controlling the corridors, controlling out into the suites themselves so that we could create a target-based registration on the measured building survey. Then when we go up to the interstitial, in very few cases we did have to do some cloud-to-cloud work, but in general, everything was target controlled and survey validated so that we could come away with a threshold, a quarter of an inch in this case, and say, yeah, everything that we have made a decision on, fit, no fit, is going to be a close fit, and we can back that with our professional liability insurance. All right. Great. So on the field collection, we found that it was the best fit with two teams. We could leapfrog across suites. We'd do one floor in about 2 nights, and completed about 800 scans for the whole of the project. The survey network consisted of about 2,500 nodes, all survey controlled and fit into the scan network. And then we minimized our interstitial scanning by using our sort of higher power phase-based high-density capture equipment. So we didn't have to pop as many tiles or take as long as when we were up there if we were using some of our lightweight stuff, which would have been nice, I can tell you, to get on the ladder and just scan around a little bit up there. But the problem was we needed to really penetrate into the gloom as far as we could with our equipment. So all of our field work was completed in December, start to finish. So from contract live to end, completely done within the month. There's our 5006 up there. And then for those of you that do this, you get the old 6000 up there. That is when you get the error. some sort. Okay, so then we get it back to the office. We have our typical standardized workflow, but we're using our post-processing and database creation as our first step to then enable our primary geometry via Edwise. So and I'll talk about this further a little bit more in the workflow, but we're basically having to bite off a night size, let's say 1 night size post-process chunk after registration so that we can begin the primary geometry generation. Then go to the next and go to the next. But what we can do now is the online QA in Edgewise, which this has definitely been one of our bigger time savers for us, is that we're not going back through, we're not pushing models from CAD space back to the point cloud in another tool. We're able to just stay in one tool all the way through now, so we can stay in Edgewise and look for completeness, and we can go direct into our native families. So post-design, what we're going to do is bring the design of the new ducting, the new MEP, back into the cloud and walk through it. And so we really use that to make a final check for the installation plan. All right. So I've got a couple of images here of the walkthrough. You can see, I'll go back to that previous one. In the suite, we're able to also identify, besides the ducting, what levels are above the interstitial space that divide the ceiling and the ceiling and the actual wall. So the client went into it actually thinking that there were no separators above the hanging ceiling, but it come to find out that over the years of changes and upgrades, a lot of walls were extended all the way up to the ceiling, particularly around the suites where they would do examinations. So this was one of the big factors contributing to the airflow issue throughout the building. So we've been able to identify quite a few of those moving forward as well and give them the view upwards. And our automated extraction, we're able to pull those, besides all of the conduit and tubing, we see all the cylinders, we're doing the ductwork as well now. All right, and then we give the amalgamated view. So on the total, we feel like just in raw numbers on this, we've saved about 10 man-days on the backside of our old workflow. So about a 25% reduction in just raw time. But the biggest changes that we're seeing is that we need less QA manager time, because there's a lot less interpretation on the initial or the upstart. I think a very positive thing is that we've got to get rid of the false positives, which there's less and less all the time, but we're not having to crawl through it from a QA standpoint the way we used to, because there's a lot less interpretation happening on the user end. So this is saving us, the time saving is not necessarily, it sort of migrates across multiple projects. It means that we can use our teams more effectively, we can use our QA folks to be able to have multiple projects in our production pipeline at the same time. Where we used to have 1 or 2, we can now do more than that. And that gives us a much better leverage of our teams as managers. So, besides the raw numbers, we feel like this is one of the best advantages of the workflow. All right, so you can see as we've come through the data, we're able to generate our solids for the layout. Wound up being a very complicated floor plan. Each floor, each cut up very different as we move through, and then we're able to isolate and provide detail on what is above the interstitial space throughout the whole facility, and providing that to a very accurate level. So for us, what are the takeaways here for us? The tenant-occupied projects and tips and tactics. Okay, so your critical fit requirement. If your client is really in need of, look, you're going to make this work, and we can stand behind that, you may consider, or you may need to spend special attention to your accuracy. some buildings, the geometry sets up great. You can use cloud to cloud. We use cloud to cloud all the time. But in certain cases, really take a critical eye to what would be the best fit. And the reason being is that an hour in the field is going to save you 8 hours back in the office. It's kind of a mantra around here, and we've seen it in action all the time. You know, if we do a little bit more in the field, you're going to save a lot of time in the back end and guesswork and sleepless nights and trying to put it together. So we see that what we see is low noise, complete data. It's faster to model, faster to register, and pays for itself on the backside. And particularly in the situation here shown in this image, when we're going to say, okay, you're going to interfere with something like an examination room where you have medical suites and everything's cabled. You didn't include that in the model, but we can see that in the point cloud, and with confidence, you need to make changes to your design or plan around it. You need to have that confidence going into it. All right, so I'm going to leave it there and hand it back to you guys. Thank you very much.
All right. Thank you very much, Kris. That's a neat project. Probably a little stressful, too, dealing with those types of requirements. Up next, Greg Hale. Go ahead and tell us about the project you did up in Rochester.
All right, thanks a bunch, Kevin, and great job, Kris. Very interesting project down there in the Capitol. So I'm going to talk about a project we did this last summer in Rochester, New York. This was a dome arena meant for a minor league basketball team back in the 70s and 80s. Over time, the facility had basically been run down. Recently, a set of developers had gotten together and purchased the building in order to rehab it and not necessarily repurpose it, but to go ahead and rehab it and make it a new event center. Make sure I get the slide progression here. Okay, so before we get into details about that project, just again a little bit more information on our company. So Hale Technology and Practice basically grew out of expertise in the design industry, structural engineering and architecture, specifically on buildings. So we've got a great background in those fields, and that's where we tend to focus. We are a woman-owned small business, which does carry its advantages for state-funded projects and government-funded projects. So that gets us in the door in many cases, and we're one of the few firms, I'd like to say, that can actually deliver as well as be a woman-owned business rather than just having the title. The focal point of the company is not specifically scanning or modeling. It is actually implementation specialists of newer design technology, and we consider scanning technology to be one of the hottest and fun technology practices these days. If anybody's dealt with it that's on the air here, it is a very interesting workflow to work with, and it gets rid of a lot of man hours out in the field and a lot of errors. So we really think it's something to grab onto and really help firms implement into their practices. We do work across North America. We are certainly primarily focused out of the Western New York region because of the reputation is a bit stronger here, but we have traveled down to Southern California, Southern Florida, up into Canada, and hopefully get some jobs over the pond here shortly. With that design technology background, there is a focus on the Autodesk products. We do have some experience in some of the Bentley platforms as well, but primarily the focus is on delivering Revit, Navisworks, laser scanning, and we do also get into the crossover with mobile technology. And as a bit of that focal point, I said we do focus on implementing these technologies into firms, but we lead by example. So we're not just saying this is how we suggest you do it. We basically lead by example and say this is how we do it, and then suggest that you do it the same way through our own trial and error and education. So let's dive into the project a little bit more here. Just wait for this slide to come over.
Greg, do you have control?
I believe so, unless you guys did the last slide here. So
Okay, let me advance
Go ahead and just,
it doesn't look like it's going
yeah,
for
if you want. Okay, just go ahead and just advance it for me then, Kevin. Okay, so specifically on this project, the Arena and Expo Center, you can see a picture there in the upper right-hand corner, is approximately about 100,000 square feet. The project scope was looking for us to scan about 70,000 square feet of it, and we had to, I would say, negotiate back and forth. Working for a developer, they're usually looking to cut whatever corner that they can. And so we went back a number of times over the course of a couple of weeks with the argument that, hey, we can send a guy out there with a tape measure and it can go ahead and sketch us all up for you. And, you know, a lot of the argument was around some of the unique geometry that was in the building and just the kind of impossibleness of truly setting a tape measure or even a laser measure to that. So we went back and forth to get that scope worked out, about 70,000 square feet of it. This particular arena is being redeveloped to be used again as an arena and an event center, where it's kind of lacked in the past number of years as it's become dilapidated. So they're really focusing on getting an existing conditions model as a point of beginning to begin design with, and they're actually currently in design as we speak. The main area of concern was that arena because of that unique geometry. The Expo Center, quite honestly, was a large metal building, and there isn't really anything too special about it, so that's part of the area that we've avoided. We were looking at an architectural and structural model primarily, but we went ahead and threw in there the mechanical, electrical, plumbing of everything that was exposed. We were not required to go into the interstitial space above ceilings. However, we did get some of that information, which has proved helpful as well. All right, next slide. So this picture that we came across here as we were developing this scan to model workflow was this focus of the ductwork. Having modeled a good bit of ductwork in the past, usually it's fairly straightforward. You've got some fairly small ductwork. It's really linear, some basic transitions. But when we started to look at this, it was very large ductwork. It was at very odd angles. And we weren't really we couldn't really figure out how we were just going to model that, even by cutting sections through a Revit model and just trying to lay it out manually. So point cloud extraction really was established as just about the only workflow that was going to get any kind of accuracy with laying out this ductwork. One of the interesting things with looking at this ductwork is, depending upon the modeling software or even the extraction software that you're looking at, usually there's a default number in there which will define the lowest angle that you can turn a set of ductwork. So 15 degrees was the kind of the magic number in here, and we were actually just below that. We were in kind of the 10, 11, 12 degree range. So it proved to be a little bit of a challenge for extracting this and getting it all connected. So as part of our workflow, we went out in the field. We actually used the Faro scanners. X330 is the latest tool set in our toolbox. As we maneuver around the building, we go ahead and do our setups and develop a scan map. Rather than having someone sketch this out, we actually take our iPads out into the field and use Bluebeam Review just to take any kind of existing plans that we have and plot out those points. So it helps us back in the office when we do our registration, as well as helping the client understand when we hand over these as-built or existing conditions models where each of their scans are at, so where they need to jump to for those existing conditions. We did not use survey control in the project. It was actually a fairly simple layout. We could almost see end-to-end if we open up a couple of doors. And I would say that the accuracy was not a critical factor. So that balanced with the price point and what the developer was looking to pay really balances that out and suggests whether or not to add that survey control. And we honestly had no issues pulling the whole thing together with some pretty tight accuracies. Site visit was made before the finalized plan and the proposal. If at all possible, we always recommend that that happens. It's not certainly not always possible, but once you get on site, you can really look at it and get a real feel for what's going on in the building and really kind of narrow down and not necessarily get the right price, but be able to ask the right questions. So if at all possible, get out in the field and try not to just jump on the bandwagon and give someone a price right away. As far as the building conditions there, it was quite an ideal situation. It was virtually unoccupied. There was really only a few people that were kind of maneuvering around the site, a couple of contractors taking some measurements. But otherwise, we kind of had our run-of-the-mill access to every nook and cranny of the building that we needed access to, and a reasonable time frame. So the scanning was unencumbered. If we wanted to get on lifts, if we wanted to get up on ladders or under floors, those kinds of things, we could do it. All right, let's go to the next slide. A couple other pictures here. This is the point cloud pulled together. With that scanning workflow, it took us about 4 days. There was one tech out in the field. There was 2 of us out there for a very short period of time, just kind of looking over the building so that both of us really had an understanding of the building to create the model from. We did actually also experiment with aerial photogrammetry. So we pulled some great aerial photos and actually a 3D point cloud from it, and then experimented with matching that to a 3D laser scan point cloud. And it came out pretty darn well, really filled in some of those holes that weren't accessible in the high spots around the roof. So experimenting with that, it's coming out as a fairly promising workflow. Over the course of that time, for the 4 days, 253 scans. We chose to do the exterior of the building in color. That helped us pull out some additional materials for the architectural model. It also certainly makes for a better render and better marketing material, not only for us, but for the clients that we work for. So when they go to either develop or design their other projects, they can present that as part of their marketing material as well. So scan data, exterior color on those doesn't necessarily provide better data, but it does provide better visuals for things like materials. Also, certainly that impacts the amount of time that you're out in the field. With the FARO-focus scanners, that's going to add about 2.5 minutes to every scan, and when you're working on a large project, that can easily add another 1, 2, 3 days to a project, and not everybody's willing to pay for that. As far as the registration goes, we use FARO-Scene all the time for our registration. We have experimented with Recap 360 quite a number of times, and it works fairly well. I still haven't got comparatively as good of results as with the native software for that scanner. We did use target registration, so it's all those little spheres out in the field, and we did use several paper targets for that, but we tend to lean on more of the sphere targets than any other method. We did also use some cloud-to-cloud registration. Quite honestly, on the project, the scan tech that was on it didn't do a great job of the target layout, and so a couple times we had to go back and refine some of those registrations with cloud-to-cloud. So as long as you have good overlap in your scans, you can get the cloud-to-cloud to work extremely well, as well as having featured in the scene. So we had both of those, and I'll say it kind of saved our butts a little bit with some bad target layout. So some of the back modeling workflow, as I mentioned, we had 2 modelers on the project, both visit the site so we could understand everything that was there, not just the scan data. One person was focusing on the architecture and structure of the building. So basically the shell, there was basically an office portion of the building, the ceilings, the lights, all of those basically shell and core features. And then we had another person focusing in on the pipe work and the ducting. And there was a little bit of conduit that was of the size that was really necessary to model, so they were also working on that. Now for that workflow, we use the Edgewise tool sets. Specifically, I want to talk in this session about duct extraction and ground extraction, but we did also use it for pipes. I just wanted to focus on that because it doesn't get talked out as much, because there's not as many situations or as high of a quantity of projects where you're looking at pipe versus duct versus ground extraction. So let's take a look at a couple of those, the duct extraction and the ground extraction. So as I mentioned before, it was going to be a challenge. There was the odd sizes, the odd angles. There's a picture of that inside of the arena. You look at that and say, wow, how are we going to, really figure out how we're going to model that? So scan data really worked well for it. And then the fact that you're using feature extraction software from point clouds really enables that process to happen accurately. So let's jump to that next slide. Let's talk a little bit more about the ductwork here. There's a picture of the point cloud versus the 3D modeled duct. So you can see the duct in blue. You can see some orange in there. That's some of the piping that was modeled around the perimeter of the arena there. There's a little bit more than that. You can see how it kind of spider webs around the building. So it's really interesting geometry. So as part of that workflow with duct, there's never anything extraordinarily standard. There's a lot of the small sizes, but what happens when you get into these unique situations, you need to be able to create your own standards. So one of the unique features of Edgewise is that you can jump in and create your own database of those sizes. So basically what you do is you go into the Edgewise tools, you export one of the standard databases that are in there. It comes out as a .csv file, which hopefully you can edit those in Microsoft Excel or any other spreadsheet editing tool. So we jump in there and we add additional ductwork up to the sizes that we needed for the project. And some of these were 7 feet wide ductwork, which isn't by any means any kind of a standard size. So we added those in fairly quickly, saved those off to our own personal Hale tip standardized duct, and then we load that back into the Edgewise software, and it uses that as part of that feature extraction. So you're not limited by just what the specific out-of-the-box features have to offer. You're allowed to standardize or customize that based upon your own criteria. So with the grounds feature extraction, basically you end up with millions and millions of points which are extraordinarily easy to use with modeling topography. So once we have that, the workflow that we use is we go ahead and look at that ground extracted file from the Edgewise file, and we optimize that tin. So on the screen you can see there's 193,000 polygons that are initially created in there. Basically you can simplify that down to a target number of triangles, and depending upon your modeling software you may want to keep that to a relatively low number. With Revit and ground feature extraction, it can actually handle a pretty high number these days, the latest versions of Revit. So we try to come in there at least under 100,000, but there might be a little bit better target depending upon the size of the model that you're creating. So once we have that and it's kind of optimized within the Edgewise product, we export that to a land XML file. So let's jump to that next slide. And then once we have that, little known to a lot of people is there's an add-on to Revit called the Site Designer Tools. And within that add-on, you can go ahead and import the land XML files directly in as a topo surface. So once you have those installed to the add-on, you go in there to the Site Designer Tools and you import that land XML. You can also do alignments if you're using Civil 3D land XML files, but this will serve as a quick, easy workflow to get in there, and you can actually further, we'll say, decimate or reduce the number of polygons once you're inside of Revit. You can see from the image, it actually comes out with a nicely flowing topo map of the ground surface. And then just as part of the final deliverable, a couple of tips here. Somebody is always waiting for that deliverable from day one. So everybody's kind of always on your back. When are we going to get it? When are we going to get it? We need to start our design process. So the pressure is always on from day one. So as part of the workflow, what we'll typically do is if there's a great need to get things in the door right away, what we'll do is we'll make sure we have the scan data perfectly registered. We're really happy with it. We've cleaned it up. and then we get that scan data to the client first. So they get an Autodesk recap file. Sometimes that's web-based, sometimes that's the hard drive, and sometimes that's actually a beginning of a Revit model. So we send that to them first. They can view those files, and while they're viewing those files and reviewing what's there on site, they can go ahead and start their process. And then while they're doing that, we'll go ahead and create the architectural model. We'll get that done as a second mode of practice. We'll basically focus our team on that, and then we'll hand that over and then develop basically the utilities above and beyond that, the MEP trades. We'll go ahead and hand that model off last. So that tries to get those teams up and running as fast as possible and splitting up that work. So if you have any ways to break out that scope and do it, once you have the scan data registered, get that to them first and then do steps deliveries afterwards. Let's see. So just a comparative workflow in here, and these are fairly rough numbers. It's really hard to tell once you've been doing this for a while what your old workflow is like. You kind of get used to the new ways. But to give you an idea on the ductwork, we estimated maybe the old workflow would take us about 24 hours. Based upon timesheets, that workflow took us 18 hours to do the ductwork and get into Revit and clean it up as the final Revit model for the ductwork. Same goes for the piping here. We've got about an estimate of 50 hours. You know, it does take quite a bit of time, even on a relatively small building, to go through quality control, you know, all of those items. But what you're doing with the Edgewise workflow is really speeding up and getting much further into the process much faster before you get to all that quality assurance. So on the ductwork, about 25% time savings. On the piping, about 44% time savings. Again, those are rough numbers. On the ground, I have done this more or less manually before, where you cut hundreds of sections across a Revit model and lay out points on a Revit topography. It's certainly not the best workflow, but on a fairly small site like this, and it's fairly flat, you know, we estimated it probably taken us about 6 hours. It cut that time in half, and it also gave us a much more accurate representation of that ground. So you can certainly cut out a lot of that time if you're using these point cloud feature extraction tools, especially if they're automated. And then just a couple of these tips and tactics. We certainly had some, apologize for saying certainly so much. We had some challenging ductwork on it. Didn't know any other way to do it than do some point cloud feature extraction. So that's where Edgewise really came in and hit the ball out of the park. The round ductwork is a little interesting in the Edgewise workflow, where those need to be extracted as with the piping tools and then established as round ducts. It's just a matter of basically the round feature extraction. Using the Edgewise snapping tools where possible. So what I mean by that is in the duct extraction, you can go back and kind of realign things because they do not necessarily line up when you initially extract them. So if you need to get things on a certain alignment or plane, there are a set of snapping tools inside of Edgewise to help clean that up a little bit when your exact feature extraction comes out a little too exact and not really, I don't want to say buildable because that's the way they're built, but truly in life things are a little bit more deformed than we like to see them in the CAD world. And just as a point of interest here, the ground feature extraction shouldn't be overlooked. It's a fantastically easy tool, and when you can go ahead and do that and extract it, it makes perfect sense once you have that Edgewise database to send that out to Revit.
All right.
All right, so that wraps me up, and back to you, Kevin.
Excellent. Thank you. Thank you both. They were both terrific presentations. I want to take a few minutes now at the end and ask you guys some of the questions that we've been getting from the audience here. First question, this is for both of you guys. I'd like to get both of your takes on this. And this is a question every webinar we do, we get this question. How do you guys decide when to use targetless registration versus targeted registration? What are the key indicators for you guys when trying to decide how to do that.
Go ahead, Kris.
Yeah, I'm happy to start. For us, I think Greg mentioned it probably best in his talk. He said that, you know, what's the best workflow that you can cost effectively do that the client's looking for that's going to best serve the client. And sometimes, you know, that key indicator may be, you know, you don't have the client's budget and time to go and do a fully targeted survey validated registration. Some instances of that are the client has come to you and has a model already. You just need to go in and validate the conditions of that model and make some changes for completeness. You know, that would be a good example. Another example is we do a lot of work in nuclear plants. And so you're in the dry well, you're being exposed to radiation, you're going to be doing cloud-to-cloud registration. You're not taking any more time than you have to be in there. So there can be a number of conditions that, you know, may dictate that, but the core principle we try to go on is making the client understand what you're doing. When you release that data to your client, you don't know what they're going to use it for unless they fully understand that. And you can contractually caveat what it may be relied upon for. The problem with the laser scans that has been done quickly, just may look good from the outside, but as you get into getting to design some steel work, say, that's at the extent of the scan or even in the overscan area, you know, somebody that doesn't have a lot of experience may look at that and look and say, oh, well, that was registered to 2 millimeters. And the person that scanned it said it was accurate to 2 millimeters. It must be accurate to 2 millimeters up here as well. So just always consider what the data is going to be used for down the road. Greg, your thoughts?
Yeah, I think that's when you dial in on the specific scope of work, that's really what dictates what happens in there. Now, as I mentioned, the tests that I've done, I've done 3 full projects where, you know, our intent was to go out there and do full target registration, but we went ahead and tried cloud-to-cloud registration in comparison to it and didn't get quite as good of results. Were they acceptable? Yes. The times where we've used it most in our actual process is when we end up with those situations, you know, you're done with the project, you come back 3 months later and you don't have targets to re-register to. You can do some overlapping scans to go ahead and do that, or sometimes there's some really tricky areas where targets are even hard to place. And so as long as you have good geometry in the scan, the cloud-to-cloud will work pretty darn well. So they can help fill in those kind of blank areas as long as you have decent overlap.
Okay.
Correct. And I'll just jump back in real quick from a measurement standpoint. When you add that cloud-to-cloud onto a network, you're not compounding potential error, or you're not increasing your possibility that you have an error. So that's very important if you take geometry, cloud-to-cloud an entire project. It'll be at the extent of that geometry where the errors have compounded. Software is still telling you it's fine, but you won't know because you won't have a validation tool to look at. All right?
Yep. Great points. All right. Kris, what were the accuracy tolerances required for your project?
Well, really, again, it's in some industries we get into, like, they really want to see a specific tolerance. For example, we're trying to fit green in on a pipe weld, and it's got to land and fit in the first time. In this case, we are working with, you know, prefabricated ducting, so it's not quite as critical as, say, like a chrome pipe fit up. But what does need to be accurate in the overall, and again, this is a fit for purpose, is that we're going to have to make some. So the engineer is going to use the data down the road to make some tough decisions about how they're going to reconfigure what's above, particularly those suites. a lot of stuff I didn't know, but if you go into like a modern dentistry suite, up above there, everything's connected like with all sorts of different cabling, with all sorts of gas and pipe tracing, everything else up there, all this tiny little services, and they're kind of all been custom built. So it's just one example up there that the tolerance really comes from the overall type of decisions that the engineer is going to make in that case. And so for that application, for me, and I'm not saying it's right for everybody, but for us and for me, we really want to be able to know that we nailed that, we validated that registration, and what we tell them is going to fit. So, you know, we tend to register in, well, we use several different softwares. We use Cyclone, we use Focus, Ferrocene, we use LFM, Aviva tools. But when we're doing a scan like this in Aviva, we would set that threshold to 5 millimeters and fully survey target each registration.
Okay, excellent. This question is for Greg, and it's from an RIT grad, by the way, up in Belgium. The question is, it's on your dome arena. What type of drone was used for the aerial photogrammetry? And also, what type of camera and software did you use for that?
All right, I'll give it a short answer since it's a little off topic, but it was a DJI Phantom Vision 2 Plus. It had basically an onboard camera with it. It comes out of the package that way, and it used Pix4D is the name of the software. PIX4D is the software that's used to register that together, and you can take that. We used the laser scan data to set up the basically more or less the ground control. It was basically a local coordinate system for that building, and it wasn't tied into state plane coordinate system or anything like that, but it was just a local coordinate system that tied the laser scan from the terrestrial scanner on the ground to the photogrammetry point cloud created from the quadcopter.
Okay, very cool. It's all cool technology. Hey, let me just take 20 seconds to remind the audience, don't forget to complete the 5-question survey on the link in the chat window. So if you go there and just fill that out, we'll compile all that information and send it out to you afterwards from everybody. I've got another question for Greg here. Can you tell us a little bit more about the scanner settings that you used with your Faro, the quality settings that you used with your Faro scanner on this project?
Sure. So I'm going to have to recall this off of memory. For the scanner settings, there is a resolution set that to be, I believe it's 1 out of every 4 potential points. So 1/4 is the resolution setting on that particular scanner. It'll pretty much give you a good target registration of about 50-60 feet between targets. So we lay that out, and then it's more in that scenario about setting up the scanner in the correct places. The distances come out pretty good in a space of that size, but it's more about getting the correct line of sight to capture the geometry, because quite honestly, you can get a very high resolution scan right in the center of the entire space because it's a big wide open space, but you're going to have very limited perspectives, and then you want better coverage on multiple sides of all those objects. So keep it to a reasonable setting. I believe we keep our quality settings to a 4x setting on that particular set of scans. And then, like I said, we did not do them in color.
Okay.
Hopefully that answers your question specific with the Faro scanner.
Yeah, that sounds good. We're starting to run out of time here. Let me ask, Actually, let me combine two more questions for both of you and just get your feedback on this. And this is something everybody's always interested in as well. How do you price your work? And then can you tell us about these projects? And don't you don't have to go into confidential details, but in general, how do you price your projects? And then for these particular projects, were they financially successful? Did you come out profitable on them? So, Kris, you wanna go first?
Yep, I'll start. The one good advantage, I guess one advantage that we have is that, I'm kind of a statistics kind of guy, and, looking back over the course of work of years and years, I'm able to come up with what I know to be the average number of scans that we complete in a day. So typically what we're doing is we're either walking a site either virtually or actually on the field to develop a very accurate scan count. And from that scan count, I've been doing it a while now, I can tell you price per scan to make that coverage and how many scans we're going to achieve on a daily or on a shift. And with interstitial space, you kind of get a little bit of a pig in a poke, so to speak, because you don't know what's up there, but you can get a feel for it, and you can also add the amount of time it's going to take you to deal with the lift, deal with the registration on the back end. So really for us it comes down to scan count, and a 200,000 square foot warehouse is going to be very different from a 200,000 square foot manufacturing facility. It's just without that scan counter estimation of the number of scans, how are you going to price it? And then what we do is we convert that into level of detail. Let's say we got a level of detail of 300 that we're trying to achieve, or 400 or 500. We'll usually develop a ratio of how many modeling days to scan days that's going to take, and that gives us a way of pricing that in man hours. And again, it's kind of a statistical based approach. We know how long those projects have taken us in the case. In this case, it was a good project for us. We turn a profit on most of the work we do. Not everything's a winner, but in general, we've got a good track record of that happening, and this was a very positive project for us.
Yeah. So I agree with everything. I agree with everything Kris said there. Basically, my process is exactly the same. The ideal situation is somebody has some kind of an existing plan that you can use as a reference. You go out on the site, you can visit it. A lot of times work is not local, so you can't necessarily do that, and you don't always get good pictures. But you can walk the site, and then basically you develop your own scan map initially as an estimate, and then as Kris mentioned, you say, we feel like we can get, maybe for this type of work, 70 scans a day. Or for this kind of work, maybe we can only squeeze in 30 scans per day. And then from there on, it's just man hours and that work. And usually the hardest part is really getting the true scope of work from the client. What really are they going to be doing with this data? So, and there's always those, oh yeah, we forgot about that space. Or what, we really need this. Can you just throw that in? So, but generally, we throw a fudge factor in on top of it, saying, we kind of expect that. And then, from there, probably the harder part is developing a price to model things to that level of accuracy, and that only comes kind of with experience. How long does it take you to model that kind of a facility or a set of objects? And sometimes, quite honestly, you stretch yourself a little bit because you haven't done that specific kind of thing either. But overall, everything so far has been successful, not only this project, but all the others. I think only maybe the first couple of jobs I didn't price quite appropriately, probably under, but that's more of getting your foot in the door.
Right. Okay. And we are just about out of time. I'm going to ask one more question, kind of along those lines. I thought this was a really interesting question. Are you able to charge a fair price? Is the question here. Contractors and competing bidders tend to drive prices too low to be worth it, hurting everyone in the long run. Do you guys have any comments on seeing this in your marketplaces?
I'll go ahead, I guess, answer on that. You know, I certainly suggest that my prices are fair. I usually fall somewhere in the middle. But again, like I said before, it's really focusing in on that scope and providing a product that's appropriate to that scope of work. And I think everybody who's doing that is pricing things fairly. It's you know, some of these others who, you know, have your college graduate out there scanning, or even a, you know, high school student out there scanning at 10 to 15 bucks an hour, you know, compared to somebody with an engineering degree or some kind of a professional license out there who knows what they're doing. Some of those things disrupt the market, but all in all, I think that the prices are settling in to be, you know, a good market rate.
Yeah, and I would support that by saying that I'm a little bit fortunate in that, you know, we don't always have to do every job. But as bad as that sounds, you know, sometimes what we do is when we start the discussion and we're really trying to find out what's important to the client, if cost is the main decision factor, then we may not be right for that client, and they may not be right for us, and we have to acknowledge that and just tell them, you know, if you're making this based on cost, you know, it's probably not where we need to be as a company. So sure, there's that. There have been cases that I've been undercut, sure, but I tell you, well, it's hard to think of not, but any time that I've ever had a job bought, I did the next job for that client. You know,
Justice.
You can get a very differential. Just undercutting the cost is not the issue. You can't do the same thing for the same cost. They're cutting it somewhere. So you need, for those of you asking that question, it's important that you have faith that when that customer, you know, they might have to take a hit or two, and it might take one or two jobs, but eventually they'll say, you know, there's got to be a better way to this, and then they'll come back to you, and cost won't be the single deciding factor.
Okay, great. Well, thank you. With that, we're going to wrap this up. Apologize for running a little bit late, but it's been a terrific 2 presentations. Thank you guys very much, and we look forward to seeing everybody again on the next issue of Workflow 4.0, our next webinar. Take care, everybody.
Everybody.